Good morning, this is your Stat Sensei, Mr. Sensei, and this is an assignment on regression, specifically focusing on scatter plots and residuals. So, adult height and weight. A random sample of adults appears to show a linear relationship between height and weight. The values from the study can be found below. Use the study below to answer the following questions. Well, the first thing I want to do is I want to go back. I have all this data and I know I'm going to have to input it. So, let's go ahead and press mode. Make sure Stat Diagnostics is on and Stat Wizards is on. They both are. If they're not, highlight them. Once they're done, blue quit. And we're going to go to Stat Edit and we're going to input all this data. Now, there's a whole long list of data, so it's easy to make a data entry error. So let's go Stat Calc, one variable statistics. And I see my X bar of 63.208. And I see a standard deviation of 4.889. So that one looks good. Let's check the other column, Stat Calc. One of our stats, blue 2. And we have 115.62 and 26.60. So I think I'm pretty confident that I don't have a data entry error. All right, so once I have that in, the very first thing it asks for me to do is to calculate the following statistics. And the way to do that is to go ahead and run the test. So stat test linear regression t-test, which is letter F, L1, L2. We want this to be set as not equal. This is real important. Green button followed by trace. If you don't do that, you're going to end up with wrong answers. All right. So remember, we learned it as y equals mx plus b, but we're going to change the order and we're going to go y equals b plus mx. But the calculator changes it up further and it says y equals a plus bx. Please note, m and b in this case are exactly the same. Those are my slope, and b and a are my y-intercepts. All right, and I should put a hat on those because we do this with a hat. All right, so it's asking for our y-intercept. Well, our y-intercept is our a, which is negative 202. So a is negative 202, and there it is. The next thing it asks for is our slope. Our slope is our b, and please remember, slope is always going to be next to the x every single time. So b is next to the x, so our slope is going to be 5.02. The next thing it asks for is the coefficient of determination. You're going to need to memorize coefficient of determination is r squared. All right, and we're going to have to scroll down a little farther to find r squared. So when we scroll down a little farther, we see r squared is 0.8529, and that's what we have. Correlation coefficient. Let's talk about that. So the correlation coefficient, even though the calculator has it, I want to make sure you understand this is 0.9235. That's our correlation coefficient. That's our R. But correlation coefficient is made of two things. It's made of sine of the slope and the square root of r squared. So let's look at our sine of our slope. Oh, our slope is positive, so our correlation coefficient has to be positive. Sine of the slope and positive. Then we're going to take the square root of r squared. So 0.8529 raised to the half power is 0.9235, and that's exactly what we have because this is just the square root of 0.928, excuse me, square root of 0.8529. So positive, and that gives me 0.9235, and that's my correlation coefficient. Now, I'll pull that directly off the calculator, but you need to know that. We'll run this real quickly again. Not changing anything, alpha trace. And because the next thing it asks for is the standard deviation of the residuals, which is 10.4348. Okay, so 10.4348. The next thing it's going to ask for is the regression equation. Now, there's a couple ways to do this. One, we know it's y hat equals a plus bx. So let's begin with that. Y hat equals a plus bx. So y hat equals negative 202.03 plus 5.025. And then we just put an x. Now that's technically correct, but a better way so you don't have to define your variables is to plug in for them. Well, my x variable is always an L1, so this will always be my x. This will always be my y. So I can put weight, because that's my y variable, and put a hat on it, equals negative 202.03 plus 5.025. Instead of writing x, we're going to put in height. All right. This is much better because you won't have to define your variables, and you'll see the advantage of that when we move on to other things. The next thing, prediction weight for 62 inches. Well, to do the prediction weight for 62 inches, I'm going to have to plug in 62 for my height. So this is going to equal negative 202.03 plus 5.025 times 62. So let's do that real quickly. Negative 202.03 plus 5.025, 62. Oop, not 65, 62. And we get 109.52. The difference between the two, between my answer and on the answer key, is just rounding. All right. This is more accurate than mine, but mine's good enough. The next one, we're going to do the same thing, but we're going to do it for 73. So we get 109.52. All right. The next one, we're going to plug in and do the same thing, but we're going to do it for 73 inches. So in this case, it's going to equal negative 202.03 plus 5.025, but we're doing it for 73 inches, which is about my height. So clear that out. Negative 202.03 plus 5.025 parenthesis 73, close those, and we get 164.795. Once again, our difference between what's on the key and here is rounding. So 164.795. This is more accurate because I went to more decimal places. And this was just because of the number of decimal places I went to. Otherwise, we did the same thing. The next thing says calculate the residuals for the following height. Well, to calculate the residuals, we're going to have to do some work. We're going to go back and run our test again. Stat, test, letter F, alpha trace. And we're going to go to stat edit. We're going to go to the top of L3, and we're going to press blue, followed by the stat button, scroll down to residual, and press enter, and it populated the residuals. Okay, so the first one it asked for 55. Well, 55 is negative 2373. At 57, it's negative 4.424. Scrolling down to 59 is negative 2.476. Then it asked for, and by the way, I'm reading 61, and that's 2.4732. The next thing it asked for 63. 63 is negative 4.578. Then with 65, is 6.3708, 67, 3.68, and then 69 is negative 9.732. All right, so that's how you get the residuals. The next thing it asks us to do is to sketch the scatter plot. So I'm going to quit out of this, blue quit, clear that. I'm going to go blue and the button above it. Make sure stat plot is on. We want the very first graph, and we want L1 and L2, L2, because that's where our data is. And then we're going to press zoom followed by the number 9. And there it is. All right, kind of a nice graph there. And like I said before, I kind of like always drawing my line of regression. It helps me put my data points in the right place. The next thing it asks us to do is to calculate a residual plot. All right, so to calculate the residual plot, we're going to go to Stat Edit. And we have all our residuals already posted in L3. So we know our residuals are in L3, and so we're going to use L1 and L3, and we'll press blue stat plot. Everything remains the same as what we had before, but we're going to change the L2 to an L3, and we'll press zoom 9. Okay, so when I look at this, I'm getting sort of a pattern to it. And because I'm getting a pattern to it, mine is starting like this and it's starting to spread out. We started close and now we're spreading out. And because it's spreading out, it says, based on the residual plot, is a line appropriate? And the answer is no, it is not appropriate because the residuals have a pattern. All right. So this one, no, it's not appropriate because the residuals have a pattern. They're starting to spread out. They started off really close together and then they're spreading out. And when they spread out, or if they get close together, or if there's a curve, not appropriate. We want something that's completely random. We want it not to look like this, where it's starting to spread out, where we obviously have a curve. We want it to look something like this. Be appropriate, it should look more like this, where it's completely random and without a pattern. It's not spreading out or getting closer together. All right, I hope this helps. Look forward to seeing you on the next one. Thank you.